Okay, so today we're going to be looking at proving lines parallel and proving lines perpendicular. So our first warm-up question, what equation represents a line with a slope of -3 containing a point 0, 2.5 in slope-intercept form? So slope-intercept form, we already have our slope. Conveniently for us, 0, 2.5, if you were to graph that, you wouldn't go left or right at all. You just go up 2.5, right? Which means that is our y-intercept. So we have both our slope and our y-intercept. All we have to do is fill in our formula. So if you remember the formula, it's y equal mx plus b. So y is equal to, m is our slope, which is -3, x plus 2.5, our b. And that's it. You didn't have to do any work with it, just filling in the blanks. Or filling in the information we do have. The next one we do have to do some work on. We want the equation of the line. We are given 2 points, so we need to find first our slope, and then we'll use point slope form, to find the equation for the line. So our m is equal to y2 minus y1 over x2 minus x1. Again, I like to label, so we need our x1, y1, x2, y2. So that means it's going to be 11 minus 5 over 3 minus 1. Just filling in with the information we know. 11 minus 5 is 6, and 3 minus 1 is 2. 6 divided by 2 is 3. So our slope's 3. So now we're going to use slope-intercept form. Y minus y1 equal to m times x minus x1. I said slope-intercept again. Point slope form. And so we can use either point, but since we already labeled 1, 5 as our x1, y1, we'll just use that as our x1, y1 here as well. So y1 was 5 equal to our slope we just found, 3, times x minus x1 we said was 1. So we got to distribute the 3. Y minus 5 is equal to 3 times x, or 3x, and 3 times -1, -3. And we add 5 to both sides. Cancels it on the left. And we're left with our answer. Y is equal to 3x, and -3 plus 5 is a positive 2. So 3x plus 2. That line goes through those 2 points. So our vocab words for today, just equidistant. The converse of the corresponding angles postulate says if two lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. So we're just reversing. Remember, converse means the if becomes the then becomes the if. So the corresponding angles postulate says if two lines are parallel, then the transversal cutting them, basically with the transversal cutting them, then the corresponding angles are congruent. Sorry about the jumbling of the words there. Anyway, parallel postulate. If given a line and a point not on the line, then there exists exactly one line through the point that is parallel to the given line. Got some more postulates. These are all just the converse of the other theorems, the perpendicular transversal, the alternate interior, alternate exterior, and consecutive interior, just the converses of all of these. Basically saying if what we know is true about those lines, like alternate interior, alternate exterior are congruent, then the lines are parallel. If the consecutive interiors are supplementary, then the lines are parallel. If two lines are perpendicular to the same line, then they're parallel. So we're just going backwards. So, knowing all this, we are given that angle 1 is congruent to angle 3. Is it possible to prove that any of the lines shown are parallel? And yes, it is possible because of the converse of the consecutive angles postulate. Or the consecutive angles postulate converse, whatever you want to say it as. So, because we know those two angles are congruent, they are corresponding angles. So that means angle 1 and angle 3 make line A parallel to line B. And the reason is the corresponding angles postulate converse. Basically what we just looked at, all of those theorems. Okay, same picture now. Now we're given that angle 1 is 103, angle 4 is 100. Is it possible to prove any lines are parallel because of that? Definitely not. We have two angles that are not congruent. One's 103, one's 100. If they were both 100, then yes, definitely we would be able to tell that A would be congruent to C, or A would be parallel to C, because they're alternate interior. However, we are not given that they are congruent, so the answer here, of course, is no. We can't prove that they are parallel because the angles are not congruent. So, no, the angles are not congruent. Shorten it up a little bit, right? Okay, so our next one, we are given that we need to find the measure of ZYN so that they are parallel. ZYN is an alternate exterior angle to WXP, which means those two should be congruent if these two lines are going to be parallel. So all we have to do is set these two expressions equal to each other. So 11x minus 25 equal to 7x plus 35. I'm going to solve for x and plug it back in to either of them to find what our angle would be, ZYN. So subtracting 7x from both sides gets us 4x minus 25 equal to 35. Then we're going to add 25 to both sides. Cancels it on the left. So we're left with 4x equal to 35 plus 25 gets us 60. Then we divide by 4 for our last step of finding x. X is equal to 15. So we have what x is. Now we need to take that and plug it into either expression. It doesn't matter which one because we know they're congruent. So that means that the measure of angle ZYN, we'll just use the one that it is, 7x plus 35. So we're just adding and not subtracting. And that means we're doing 7 times 15 plus 35. 7 times 15 comes out to be 105 plus 35. So the measure of angle ZYN is equal to 140. Okay, so we want to see if, to ensure that the wood pieces that run throughout this window are parallel. So, how can we check that? Pardon me. There's a couple ways we could do that. We can check it, really there's 3 ways. We can check any of the angle pairs, right, that we know we need to be congruent to be parallel. So, you can check any of the angle pairs corresponding alternate interior, alternate exterior for congruence. So if any of these three pairs, we have some corresponding angles, we have alternate interior or alternate exterior angles congruent, that means that the lines that make those are parallel, and we can just check that several times throughout this, and we should be able to do that pretty easily. Just using a protractor. So the distance between a point and a line. The distance between a line and a point not on the line is the length of the segment perpendicular to the line from the point. I'm going to go ahead and warn you now, these problems are going to be long. And so the perpendicular postulate says if a line and a point not on the line, if given a line and a point not on the line, then there exists exactly one line through the point that is perpendicular to the given line. So our first problem here are actually, please hold. Okay, sorry about that. I changed the problem and I apparently did not save it, so I had to go fix that. Alright, so this is the problem I want to do, not the one that was listed there. So which segment represents the shortest distance from point A to DB? DB is the line going horizontally across the kite, and X is the point in the middle of the kite, A is the point at the top of the kite. And since A goes directly to the middle at DB at X, so that means our segment that we're looking for is just AX. Much easier problem, and not nearly as wordy as that last problem was. So, sorry about that again, but fixed it. Here we go. Alright, so we've got two more problems to do. These two are the lengthy problems, alright? So our next one here, we're given some points, 1 point off of the line, 2 points on it. We want to find the distance between point S and point V. So what we need to do first is find the equation of the line that is at V, or goes through V, and is perpendicular to the line S. Once we find that line, the equation for that line, then we need to find the distance between the point on that line and the point where they intersect. So, it's a long process here, okay? So, the first thing we need to do, find the slope of the line we do have. So that's easy. Rise over run. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now the nice thing here is because we're given a graph, we can actually use that to our advantage. So we're going to do MS, the slope for S. We just said it's 5 over negative 5 because we had to go to the left. So it's negative 1. So remember, we're looking for a line that's perpendicular, so that means the measure of our line, we'll call it R, is just the opposite reciprocal. So if this one's negative 1, we're positive, and 1 over 1 is just 1. So positive 1. Pretty easy. So now, what we need to do, if we were to do this by hand, we would need to find the equation for the line that goes through this point 1V, and it has a slope of 1. So we're going to use point slope form. Y minus the y value at V is 5 equal to our slope of 1 times x minus our x value at V, which is 1. So we distribute the 1, y minus 5 is equal to x minus 1, and we add 5 to both sides. So y equals x minus plus 4 is our equation. Now, that's our equation for, this is our equation for R, right? The line we don't have yet. Now, for the equation for S, we know its y-intercept is 0, mx plus b, right? So our m is negative 1, so it's just negative x. So now, we need to set these up as a system of equations to find the point where they intersect. That's pretty easy because they're such simple equations. So we just plug in what ys is for yr. So that means that we have negative xs, or negative x, equal to x plus 4. And if we subtract x from both sides, we get negative 2x equal to 4. And then we just divide by negative 2. And x is equal to negative 2. Now we plug that back into either of these equations, and since s is the more simple equation, y is equal to negative of negative 2, so y is just equal to 2. So the point where you're looking for is 2, or negative 2, 2. So that's the point where they intersect. Now the last step is to find the distance between that point and v, and we're done. So we're going to use the distance formula. Everybody's favorite, right? So our x1, y1, our x1 and x2 are going to be negative 2 and 1. So negative 2 minus 1 squared plus our y's, so keep them in the same order, right? Since the x we used was negative 2 first, the y we need to use is the 2, and 2 minus 5. So that is going to be negative 2 minus 1 is negative 3 squared, plus 2 minus 5 is also negative 3 squared. So that's going to be the square root of 9 plus 9, or the square root of 18. You can answer it as just that, or if you want to get the decimal amount, the distance is about, it's not equal to, is about 4.24. Alright, so that was our perpendicular, our distance between two lines that would be, or a point in a line that would be perpendicular. So now what we're going to do is look at distance between two parallel lines. The distance between two parallel lines is the perpendicular distance between one of the lines and any point on the other line, because if it's perpendicular to one, we know it's going to be perpendicular to the other. In a plane, if two lines are each equidistant from a third line, then the two lines are parallel from each other. That's the two lines equidistant from a third theorem. So here's our last problem. We have our two lines. We want to find the equation for P. Now P doesn't have to be where it is, because we're just looking for the distance. But the convenient part about P is that it has the same y-intercept as our second equation, line B. The y equaled 2x minus 1. So we have a point already for that one, and that means we have a point where they are going to intersect. So first thing first, we know one of the points on our new line, perpendicular, is the y-intercept, 0, negative 1. And we can use our slopes from our other two equations. The 2, so m of b is equal to the m of a, which was 2. Then our m of p is the opposite reciprocal, so negative, flip it over 1/2. So the equation for P we're going to get using our point slope form. So y was negative 1, so y plus 1 equal to our m, negative 1/2, times x minus 0. When we distribute the negative 1/2, y plus 1 is equal to negative 1/2 x, and negative 1/2 times 0 is just 0. Then we subtract 1 from both sides. So y is equal to negative 1/2 x minus 1. That's our equation for P. So now we need to find where P would intersect A. So we're going to use a system of equations. So we can just set these equal to each other, where it's 2x plus 3 equal to negative 1/2 x minus 1 to get our x out. So I'm going to do everybody a favor and get rid of the fractions by multiplying by 2 for the whole thing. So that means that we end up with 4x plus 6 equal to negative x minus 2. So every single thing multiplied by 2. Now it's a little bit easier. We just add x to both sides. (5x plus 6 is equal to negative 2. Then we subtract 6 from both sides. And 5x is equal to negative 8. And we divide by 5. And our x value comes out to be negative 8 over 5, which is the same thing as negative 1.6. Give it as a decimal. Okay, so now we need to find our y, so we can plug that back into either equation. And since our a equation has no decimals in it, or fractions, make it a little bit easier. So y is equal to 2 times negative 1.6 plus 3. Negative 2 plus 3. I'm sorry, negative 2 times negative 1.6. 2 times negative 1.6. Sorry, would be 3.2 negative plus a 3, which means that y is equal to just negative 0.2. So we have our point on the other line where A would intersect P. So now we're going to take these 2 points and find our distance. So that means we're going to have our x's, negative 1.6 minus 0 squared plus negative 0.2 minus negative 1, so plus 1 squared. Running out of space here. So d is equal to the square root of negative 1.6 squared plus 0.8 squared. So that's going to be 2.56 plus 0.64. So d is equal to the square root of 3.2, or about 1.789. Okay, sorry for the length of the problem. Just is what it is. These problems take a bit. So here's your exit ticket. Find the distance between the parallel lines that are given to you. You don't have a graph here, but you can still get the y-intercepts for each one. Use one of them as one of your points. Make it easier for yourself.